Hey, this is going to be the video key of the chapter 3 review, and I'm just going to begin. I'm sure it'll be kind of a long video. You can scroll through it as we go. So, number 1a, I have g of x is equal to 2 minus x squared. Remember, my parent function here is g of x is equal to x squared. Notice the transformation, or actually the polynomial is not written in standard form. I always like to write my function in standard form when describing transformation. Sometimes it could just make it look a little bit more familiar. And so I'm going to rearrange my terms. And I notice my two things. I've got a x-axis reflection. And then I have this up 2 units. On B, this is function notation transformation. So if I have g of x, then I'm going to look at another function that has been multiplied by 2. And f of x was x squared. So this is a vertical stretch by a factor of 2. Now remember, if it was horizontal, just as an FYI, it would look something like this, and that would be a horizontal compression, just in case if you forgot about the two different ones. Okay, number 2, I have the graph y is equal to x squared plus 4x plus 3, and it wants me to identify the vertex and the x-intercepts. Well, there's two ways you can go about this. I'm going to go about it by completing the square to find the vertex. So this is a nice one because my a is 1. So all I have to do is right away find the perfect square trinomial. And that's found by taking half of this middle term, dividing it by 2, and then squaring it. So 4 divided by 2 squared gets me back 4. And that should be enough to make a perfect square. I'm going to factor that to x plus 2 squared. But since I added 4 here, right, I have to have a net impact of 0 on my equation. So I'm going to subtract 4 off of here, and I'm going to write -1. So my vertex is the transformation -2, -1. Okay, so that was one way you could have done this one. The other one is x equals opposite b over 2a. Remember that part of the quadratic formula without the discriminant, the square root part. And my b was 4, and my a is 1. So I get -4 divided by 2, which is -2, which matched up with when I completed the square. And if I know my input value and I want to know its corresponding output, then I know I just plug that into the function to find y. And I should be getting 1, because that's what I got when I complete the square. And that's what I get. 7 minus 8 is -1. Okay, so those are your two options for finding the vertex. And the x-intercepts, you could factor or use the quadratic formula, right? So x-intercepts are where my y is 0. I'm going to set my y equal to 0. And this is a nice factor. If it wasn't nice and factorable, then I would definitely use the quadratic formula. And there's my y's being 0, right? That's the reason I said equal to 0. Those are my x-intercepts. I also could have over here solved my vertex form, I could have set this equation equal to 0. Square rooted. There were some students that had forgotten the square root method, so that's why I want to go over this. Subtract it by 2 over, and then I get my double solution. -2 plus 1, which is -1, and then I get -2 minus 1, which is -3. I get the same x-intercepts, but just make sure that you can at least do this one over here where I completed the square. It's also great to know a negative b over 2a, especially when you have a quadratic that is really complicated. If you have coefficients that are decimally or crazy, then you'd want to use negative b over 2a. Okay, number 3. I have h of t is equal to negative t to the 5th plus 8t squared. And it says determine the left and right hand behavior. That's just my end behavior. So as x goes to negative infinity, that's the left side. And as x goes to positive infinity, so this is my left arrow on the graph, and this is my furthest right arrow. And I'm going to tell whether it's going to go up or whether it's going to go down. This is what I'm going to fill in. That's my part. So I'm going to look. This is a 5th degree, which is an odd degree because 5 is an odd number. And the leading coefficient attached to that is a negative. So we just take any odd function and we just say it's going to have the same end behavior as a cubic, right? And that's kind of what a cubic looks like, but it's been reflected across the x-axis. So now we know it's something like this. So to the right, it's going down, and to the left arrow is going up. So there's my end behavior. And then it wants me to sketch a graph. So this is the hard part of this problem, okay? So obviously if I want to sketch this graph, and this is just a rough sketch, then I'm gonna, besides knowing that I'm gonna fall down and rise up, I need to know a little bit more information. It is a 5th degree, so we know there's a lot of abilities for it to have lots of x-intercepts, right? A total of 5. So I noticed that I'm going to set this equal to 0 since it's a binomial. And it looks like it has some common factors. It's going to have 2 x's that are going to come out, and I'm going to take the negative with it. And I notice first thing right off the bat is I have this t occur twice, which is my x-intercept at 0, 0, right? And that's a double that bounces. So I know at 0, I got to bounce. I also know since 0 is an x-intercept, that's also my y-intercept, so I don't have to go separately and go ahead and find that one. Okay, so now what I have to handle is this cubic binomial, and this definitely looks like a difference of cubes because I can write 8 as a cube. And that's what I lead off, and then I have this trinomial that we create, right? And so I know I have another x-intercept at x equals 2, and that occurs once, so it crosses. Then the next thing that I'm going to do is, you could do this part, but hopefully we have enough recognition because when we did these, we talked about it a lot. When I do my square, my first term, which is t, then multiply my 2 terms together, 2 and t gets me 2t, don't worry about the signs. And then square my last term, which was 2, which 2 squared is 4. And then remember, SOAP is our sign, same, opposite, always positive. But if we remember when we factored these and we were solving, I said you never have to solve that trinomial for 0 to find x-intercepts because they'll always be complex. So they're not going to be visible x-intercepts. you'd have put that in the quadratic formula and you'd find that you'd get a square root of a negative number. And it only asked for a rough sketch. It's not asking for us to find all the solutions. So now I know that this fifth degree has two complex and then three reals because I have that double root at 0. So I have found all my solutions. Now I'm just going to give a rough sketch, bounce, come back through, and there's my end behavior. Something like that. Okay. And number 4, I want to long divide and synthetically divide this function. So it's 2x to the 4th minus 5x squared minus 3 divided by the linear polynomial. Now remember, when you divide by a linear, you can definitely synthetically divide. You put the 0 or the x-intercept in the corner, and then if it is a 0, then you're going to get a remainder of 0. Notice that this is a 4th degree, so 4th degree goes 4th, 3rd, I didn't have a 3rd, 2nd, linear, constant. So I had a couple 0 placeholders to put in there. Now I'm just going to multiply and add, multiply, add, multiply, and I get a remainder of 9. Now remember, this is an important thing to do, to remember, is when you do synthetic division, right? This is a point. When my x is 2, my y is 9. This makes a coordinate point. So if I took this 2 and plugged it in to this function, it would output the remainder 9. Okay, that's important to know. Okay, other than that, also with synthetic division, the 1 degree lessons are divided by a linear is a cubic down here, and these are the coefficients that I'm on. And then my remainder is usually my remainder divided by like that. That's how you would traditionally see it. Okay. I did synthetically divide first because I know that that answer is right. Synthetically dividing is a little bit easier. Not necessarily easier, but there's a lot more error when you're doing long division. So at least I know my answer over here. So I know the first term I'm going to use is 2x squared. Now I'm going to distribute in, and that gets me 2x to the 4th. And then minus 4x squared. Now remember, I'm subtracting. So when you subtract, you have to distribute the negative into both terms. That's going to cancel off my leading. And then I'm left with negative x squared plus 0x minus 3. A lot of times when you add these zeros in, you do skip solutions. Oh, I misread that one. So let me backtrack. I multiplied by the right one, right? So 2x to the 4th. Now this one gets me negative 4. Sorry about that. X cubed. And I would have to change my sign. There we go. Probably watching, wondering why I did that. Okay, so now I'm going to multiply what multiplies by x to get 4x cubed, and that would be plus 4x squared. And then I get 4x cubed, and I get a negative 8x squared. Distribute my negative in because I'm subtracting, cancel out my leader, and then I get 3x squared plus 0x, and I'll just go ahead and bring my 3. And what multiplies by x to get 3x squared, that would be a 3x squared, and then I get a minus 6x. Distribute my negative in, get a plus 6x, bring down my negative 3, and I'm going to